Good evening, friends. A very warm welcome to Artsy Clicking Sessions, session 10, and thanks for logging in. I am Dr. Archana Tandon, a gynecologist by profession and a passionate photographer. I believe that each one of us should give in our best to the subjects of our choice, for which one should skill oneself in the subject by learning skills and educating oneself properly. So I did my MBBS MS in Obs Gynae to give my best as a gynecologist and did diploma in photography to pursue my passion. I'm also thankful to Mr. Mark Hemmings of Photography Pro and William Eames of Shaw Academy who helped me acquire my photography skills. Giving free education is a social service that I had longed to do for the society for long in subjects that I know something about. Today's topic is perfecting aperture priority mode. Let us learn to use it for profile photographs and landscapes by using different apertures to obtain various depths in our shots. Let us talk about plane of focus and what is bokeh too. So, what is an aperture? As you see here, an aperture is an opening that allows something to pass through. This is the opening, and this is the shutter, which is opening and closing for this opening. In a camera, it allows the light to pass through. We use aperture mode if we want to control depth of field. If we want to catch really sharp images like in this landscape where all the structures from the foreground to the background are in focus and are sharp, or when we want to draw attention to something which is in focus in a faded background like this, these flowers are in focus whereas the background is blurred, or we want a shallow depth of field, shallow enough to blur the background to highlight the structure in front of it, or we want to show how small the world is around these creatures, these small creatures, or we want to draw attention of the viewer to a defined subject, blurring the other. Like here, this lady is blowing out the petals, and if we take a photograph, we can blur the lady whereas highlight the petals in front. Or we want to capture soft reflections in background of focused lights in the foreground. Controlling the depth of field to draw the viewer's attention to a particular object or to capture each and every element in frame sharply to create depth will open up the possibilities and make capturing photographs all the more interesting. So, we can say apertures are used to control the amount of light and the depth of field. This is how the aperture opens and closes to let in light. The size can be variable and we can control it. So in last session we had a look at the aperture triangle, and we talked about shutter speeds and how shutter speeds control time in this exposure triangle to allow light to pass through a certain period of time for the exposure. It's now time to look at the second factor, that is the amount of light that gets in, which is controlled by the aperture for the exposure. Aperture controls the volume of light or the amount of light that is allowed to get in and fall on the sensor for the exposure. So, the third part we will be discussing in the next session. Apertures work the very same way that our eyes work. So, we all know very well what happens to the pupils of our eyes when we enter a dark room. Our pupils dilate to increase the amount of light that enters our eyes to make us see reasonably well in the dark. The opposite happens when we go out in the broad daylight. So, dilated pupils, more light enters the eye. Constricted pupil, less light enters the eye. So, smaller the f number, this is f 1.8 and this is f11. So, smaller the f number, larger is the aperture. So, inverse. So, more amount of light enters the camera to form the image. Larger the f number, smaller the aperture, less the amount of light that is allowed to enter. So, the aperture diameter can be controlled depending on how much light you want to enter for a proper exposure. Apertures are expressed in f-stops. We sum up the points discussed till now. So, apertures are expressed in f-stops or f numbers. Each lens has a certain range of standard aperture sizes. Smallest aperture goes up to f22 universally, and some have higher numbers. Large or wide aperture varies from lens to lens. Aperture range is displayed on the front of the lens like 1:2.8 or 1:3.5 to 5.6. So, apertures can be of different shapes depending on their blades. Nikon has 7 to 9 blades, Canon has 8 blades. That might sound complex, but we will soon be taking it up to explain it. Remember these points and please don't get confused here. Last 2 points that is large or wide aperture varies from lens to lens and aperture range is displayed on the front of the lens like 1:2.8 or 1:3.5 to 5.6. The lower the f-stop, the wider the aperture, meaning more light, and the higher the f-stop, the smaller the aperture, meaning less light goes in. So, do remember these points. Let's look at certain examples. Look at your lenses from front and try to identify the numbers written in front of it. Lenses will display the widest aperture available to you. Not all lenses will have the same widest aperture, so this lens, which is a 50 mm lens, has a number written in front which says 1:1.4. So, the widest aperture in this lens available to you is 1.4. lenses with wide aperture are known as fast lenses because they can let in so much of light, and so even faster shutter speeds can be used. The second one is a zoom lens, so the display is different. Here you just see 1:1.4, but here you see 1:3.5 to 4.5. So what does that mean? Zoom lenses have variable smallest apertures for use. The numbers indicate that when you zoom in, the aperture will close down, become smaller automatically. So for example, at 28 millimeter, this is a zoom lens of 28 to 105. So at 28 millimeter, widest aperture available is 3.5, and at 105 millimeters, widest aperture available is 4.5. The reason is because zoom lenses are economical. That is, it is all about cost of these lenses, because a lens is doing so many jobs for you. Here, prime lenses with wide apertures are costly. For example, a 24 to 105 f4 lens, that is a prime lens with focal f4 lens, can be a lot more expensive because you can get an aperture of f4 at any focal length compared to an 24 to 105 1:3.5 to 4.5. Here the f number will vary depending on what of zoom you are using, where the aperture is going to change automatically when you zoom in from 28 to 105, from 3.5 to 4.5. In prime lenses, the aperture will remain the same even after zooming in. So don't get confused, practice and you will start understanding. For now, look at your lenses, see the numbers on it and try to gather what they mean. What does F stand for? I have been saying F number, F number. Now what does that F stand for? In optics, the F number of an optical system such as a camera lens is the ratio of a system's focal length to the diameter of the entrance pupil. It is also known as the focal ratio. So F ratio or F stop, and is very important in photography. And F stop is calculated by focal length of the lens divided by iris opening of the aperture, the diameter of the iris opening of the aperture. So for example, if you have a 50 mm lens with entrance pupil aperture of 2, divide 50 by 2 and you get 25 mm. So this 25 mm is the actual size of the aperture opening. Now you know where F comes from and what it means. Remember, we are only concerned with what an F number does and how to control it, and control it for our photographs. The actual number or the value or the ratio does not count. So don't get confused. Just remember that lower the F number, larger the aperture, more light goes in. Larger the F number, smaller the aperture, and less light goes in. This is the most important. Optics, if you can gather, then it's okay. So let us look at the aperture, that is the numbers available to us and how to make use of them. Commonly they range from 1.4 to 22. But we have 1.2 and lower 2 and can go as high as 32 to 64. But this is the standard range. For shallow depth of field where you need a blurry background to highlight a subject, like in a portrait or macros, you need lower f-stops from 1.4 to 4. For landscapes and architecture where you require everything to be sharp and clear, And in focus from foreground to the background, you need higher f-stops numbers from f11 to f16. So a wider aperture gives a shallow depth of field used for macros and portraits, where you want a blurred background and focused subject, and for a landscape or a architectural photography you require larger f numbers from f11 to f16, so that everything from foreground to background is in focus. Though f8 is the number where you usually get the sharpest focus. Everything is in focus at that number. Did you know the equivalent f-stop value for human eye are f8.3 in bright environment and f/2 in the dark? Let us identify where are apertures displayed on our LCD screen viewfinder. They are right beside the shutter. So this indicates the shutter speed, and this is the f number in your LCD. This is in your viewfinder, and some lenses, some old cameras have some old lenses have the apertures indicated on the rim of the lenses. To sum up the characteristics discussed till now about aperture priority mode, I'd like to sum up. It is a semi-automatic mode. Sometimes appears as AV, aperture value, in some cameras. You can set the aperture size here, that is the lens opening size, and camera will control the rest. Controlling aperture controls the depth of field in the scene, as we talked in the previous slides, and it is a great way to learn apertures and depth of field in action. So now let us talk about aperture priority mode and its uses. Switch on your camera to aperture mode and try out all different f-stops to see the different effects. Aperture selections are limited to the type of lenses you are using. Not all lenses have the same aperture sizes on the lower and the upper side. So depth of field, controlling the apertures. What does controlling apertures do? Controlling apertures can be controlled by using adjustment dial, or in some lenses it can be adjusted directly by using the aperture ring. So some cameras have this dial where you have this marker here, and you keep A to match with this marker, and then you have this dial which you rotate to set the aperture size. Some cameras have two dials, and one is for shutter, the other is for aperture. Some cameras do not have two dials, and then you use this plus minus, that is the button present on your camera, which is an exposure compensation button. So you press that and then rotate this dial. So when you do not press this, it works for controlling it displays the shutter speed. If you press this and rotate, it displays the aperture. And some lenses have the apertures depicted on the rim. So check your camera manual to know exactly where your aperture control is located on your camera. So controlling aperture controls the depth of field. What is plane of focus? The plane of focus is the distance from the camera at which the sharpest focus is obtained. So if you click a photograph and the face and the back of the deer is in the same plane, and if you draw a plane vertically from this, that will denote the plane of focus where everything is sharply focused. And we can also say it is where we choose the focus in a photo. Depth of field will extend from this point. Shallow depth of field has a shallow depth and has a blurred out of focus background and foreground. So you can see that this is a bit out of focus, this is also a bit out of focus, and so depth of field is controlled by the aperture you choose. This is the focus depth and this is the out of focus foreground and background. The shallow depth of field extends around, the depth of field extends around 1/3 in front and 2/3 behind the subject from the plane of focus. That is the plane at which you have obtained the sharp focus. Depth of field extends 1.3, 1/3 in front and 2/3 behind the plane of focus. Remember, it is obtained by using a wide aperture, a lower f-stop number. Deep depth of field is just the opposite of shallow depth of field, and a deep depth of field has a sharpness throughout the entire photo from the foreground to the background. Everything appears sharp as seen in this landscape. It is used for landscape, architecture and photography. So here you use a f-stop of f8 and above. Above f11 to f16 can be used to get when you want everything to be in focus. And if I'll magnify this, you can see here the focus, and one moves the, even this is in focus, everything is sharp and focused. You can even see this tent over here which is sharply focused. So let us see how depth of field works. So here is a photographer who is photographing people standing in a line. These children are standing in a line and this photographer is photographing them. For the first photograph, he chooses the aperture of 2.8 and focuses on the first person. Remember, we will be keeping our point of focus on this very first person in front always for all other photographs in succession that we take as we change apertures from f4 to f16. With f4, first two are in focus. With f5.6, the first four children will be in focus. With from f8 to f16, we will notice that each and every child in the photograph will be in focus. So we conclude that with lower aperture the depth of field is less, and with larger aperture the depth of field has increased. So aperture controls the depth of field in the scene, but it does not determine the focus. We still must select where in the photo we want to focus. We again take our camera and keep the aperture constant at 2.8. This time we won't be changing the aperture, but we will be keeping it constant at 2.8. That is at the lowest depth that we can obtain, and change the point of focus. So we will be focusing first on the first child, then on the second child, then on the fourth child, and we can go on and on And we will see when we are focusing on the second child, the first child and the child behind, all the children behind the second child will be blurred out, and we will be able to get a clear picture of the second child, sharply focused second child. So now I hope I am clear about uh, how the apertures affect the depth of field, and how to make use of it to get your focus on the subject which you want to capture. Now let us talk on what is bokeh. Bokeh is not the depth of field or the blurred background which is produced by the shallow depth of field. Bokeh is the aesthetic quality of the blur produced. The quality of this blur produced in out of focus parts of an image. It is the way the lens renders the out of focus points of light. Differences in lens aberrations and aperture shapes causes very different bokeh effects. So different lenses produce different types of bokeh effects. Some lens designs blur the image in a way that is pleasing to the eye, while the others produce distracting or unpleasant blurring known as good or bad bokeh. Bokeh is often made most visible around small background highlights such as specular reflections and light sources, which is why it is often associated with such areas. However, bokeh is not limited to highlights. Blur occurs in all regions of an image which are outside the depth of field. So on the lighter areas produce a pleasant and aesthetically beautiful bokeh in images, and if you have a light source behind, it produces a beautiful bokeh. So to get a good bokeh, use prime fixed lens for best results. Here the lights filtering through a tree has produced this bokeh effect. So use prime fixed lens for better results. Use widest aperture possible. Choose focus on the subject. This increases the depth of field, hence the effect. So wider the aperture, better will be the bokeh, because depth of field will be decreased. So place the subject far from the background you want, and there should be distance between the subject and the background, and different lenses produce different bokeh shapes. Try different light sources also for like I've used here the light filtering through the tree. So we have covered the aperture priority mode, and next section we have in this exposure triangle we have already discussed how the shutter speed affects the exposure, how the aperture affects the exposure, and the next session we will be taking up ISO and how ISO affects an exposure and what it does and how to control ISO. We will also be discussing as to how to better focus on our images. So I hope by this time everyone must be clear in their mind that if you are altering the shutter speed from then maybe you have to compensate by altering these two sides, that is ISO and aperture. If you are altering aperture size to get a good exposure, you will have to change these two sides for a better exposure. So it is a balance of aperture, ISO and shutter speed which one uses for good images. So it's time for dinner and it's time to say good night. And this is a photograph which has been taken with an ISO 20,000. So we'll be talking all about ISO in the next session. And if you have any queries, you can always email me on tandanarchana@gmail.com or WhatsApp me on my mobile number 75992 95951. A great day. Good night. Have a great day. See you in the next session of how does ISO help us in getting our exposures. Thank you for logging in.